y is equal to negative 2x minus 1 and y is equal to x plus 2. Let's start first by drawing the two linear functions. Now, revision. We said we look for the x-intercept. X-intercept. When we do that, we put y equal to 0. This will be 0. Transposing the two negative 2x and positive. Two x is equal to negative 1. Now, we're looking for x not 2x. So we divide right through by the 2, and x will equal to negative half. Expressing that in x and y, coordinate will be half. We said y is 0 up here. Then set number 2 here. Y intercept. We get x equal to 0. From the top graph there, we have y is equal to negative 2 times 0 is 0. Let's go back. We have negative 2. And we say our x is 0. Down. Anything multiplied by 0 is 0. Answer is negative 1. In the coordinate form, x is 0, y is negative 1. And this one is easy. One is that x-intercept, you let y equal to 0, and x will be negative 2. But this will be 0, transpose that 2. And number 2, for y-intercept, we let x equals to 0, y will be 2. So x here, y is a 0, here x is a 0, y is a 2. And then let's plot the 2 and see what happens. When we name them, we label our function there. So here 1, 2 there, minus 1 there, minus 2 here, 1 there, 2 there, 3, negative 1 there, negative 2 there, negative 3. Let's plot the coordinates. First one here, we have our x is a half. This one here, and this one here. All right. And then for this one here, when x is a 0, y is a 2. When x is a minus 2, let's join the dots. Right. And then we go to this one's here. Now, these two graphs here meet at a particular point. Let's call this point N. Now, at this N, which is the point of intersection, is where the two graphs are equal. Now let's look at the graph themselves. Said y is equal to x plus a 2. And then that side we have y is equal to negative 2x minus 1. If the two functions are equal here, we can equate that, which means negative 2x minus 1 will equal to x plus a 2. I repeat, I say if you say the two functions are equal at point N here, y equal to y, if this y equal to y, it means this is equal to this. They're both y's. And anyway, if we transpose to this x this side, we have negative 2x minus x is equal to 2 transpose 1, comes change sign here, minus 3x is equal to a 3. So which means x is equal to a 3 divided by the minus 3 there, which will give you, it means you have divided both sides by negative 3, which will give you negative 1. Therefore, x is equal to negative 1. So they meet somewhere there. Now, you can look for y there. On the blue one, this one here, when x is a minus 1, we have y is equal to, for x here, we substitute minus 1 plus 2, and the answer is 1. Therefore, when x is a minus 1, y is a 1. Now, this coordinate here, n, satisfy this blue function here and that blue function at the same time, simultaneously, at one and the same time. What do you mean when you say the coordinate n satisfies both functions at point n? We mean if we choose x is equal to -1, we know that our y must be 1. If not, something wrong with our arithmetic. But from this coordinate, it is clear that when x is a -1, y is a 1. Because this is x, and that's a y. That's what we have. So, if you can substitute for x is equal to 2, we can't get 1. We only, or if we substitute y is equal to 1, surely we must get x is equal to -1. That you can do as a substitution. That's why we say this coordinate satisfy the two equations at n at the same time. That's where we have the word simultaneous, at the same time. Now, we are going to have a look at two more sets of functions which we solve simultaneously. Now, this is graphical representation and solution of this equation here that shows that they are equal at point n. Now, let's have a look at this ones here, where we have 3y is equal to -x plus 5, and we have y is equal to 2x minus 7. Now, this graph here is of the form y equals mx plus c, but this graph is not in the standard form. It's not in the form y is equal to mx plus c, which is the standard form. The standard form. So we need to write this in the standard form so that we can make our life easy. We divide right through here by 3. So we shall have y is equal to -1/3x. Remember, there's 1 here, invisible 1 here, plus 5/3, where our c is 5/3 and our m is -1/3, the gradient. M, the slope, is our gradient. Now, having managed to successfully write this expression in a standard form, which is that, then the other one says y is equal to 2x minus 7. Now, if you solve this simultaneously, we are going to say y is equal to y. So I can as well say y is equal to, I can say 2x minus 7 is equal to y, but the same y is equal to -1/3x plus 5/2. So this is equal to that because they are both equal to the y there. So you can write that as 2x minus 7 is equal to -1/3x plus 5 over 2. Transposing this side will be 2x plus 1/3 x is equal to 5 over 2. Transposing the minus 7 becomes 7 over 1 there. 2 plus 1/3 is 2/3. It's 2 and a 1/3. X is equal to, this can be written as 5 over 2 plus 7 over 1. But so that we have the same thing, and multiply by 1, 2 over 2 is same as 1. And that will give you 5 over 2 plus 14 over 2. And here we have a mixed fraction. We write that as improper fraction. 3 times 2 is 6. 6 plus 1 is 7. That is 7 over 3. So we have here 7 over 3x is equal to, LCM limited here is 2 times 5 plus 14, which is 19. You can say 7 over 3x is equal to 19 over 2. 7 over 3x. We want the value of x, not 7 over 3x. Now, we get rid of that. We multiply here. We multiply here by 3 over 7. The same this side, we multiply by 3 over 7. This will drop with that. And this will drop with that. We shall remain with x is equal to, the bottom one will be 14. And 19 times 3, 19 times 3, 9 times 3 is 27, carry 2. 2 plus 3 is 5. This will be 50. That will be 57. That will be 57 over 14. So now when you have the value of x in a coordinate, it will be x, and then you look for the value of y. You can push in the value of x here. So we shall say y is, let's go to y is 2x minus 7. That will be 2 into 57 over 14 minus 7. 2 here was 2 here 7. That is 57 over 7 minus 7. 7 times 7 is 49. So it's 56. 7 goes here 8 times. 8 1 over 7 minus 7, remainder 1 over 7. So your coordinate is going to be 5, 7 over 14, and then this one is 8 over 7. Now we managed to solve the two linear equations simultaneously, and then that is our new n where they meet. We shall have a look at the next one, and the next one will be the next one will be uh, the next one will be the next one will be will come in the form of 2x minus 1 is equal to 2, and y is equal to negative that. Here we can say 2x minus 2 is equal to 2, and here we have y is equal to x minus 1. So we are going to equate that to that because they are both equal to y. So 2x minus 2 will equal to x minus 1. Transposing that, this side is going to be 2x minus x minus 1. Transposing that, plus 2x minus x will be 1x. That's going to be 1. So x is 1. We need to get what y is. If x is 1, if I put 1 here, 1 minus 1 becomes a 0. Therefore, that's the solution for that. Now, this was a linear and a linear. This method of simultaneous solution of functions can be applied to a linear and a parabola, or linear and hyperbola, or parabola and parabola, and linear and hyperbola, whatever you are given, or hyperbola and a circle. So we are going to have a look at a linear and a parabola, and then go and have a look at a linear and a hyperbola, or a parabola and another parabola. We are going to start first with a linear and a parabola. And then what you're going to do is to write the linear, our linear first, and our parabola.